you had definition number 1 for your test. What was definition number 1 for slope of a line tangent at a given point? Slope was equal to the limit as, who remembers? X approaches a of f of x. Okay, I'm going to show you today definition number 2, okay? And I don't have space in your notes, so we're just doing some scratch work here, but I know that you're going to memorize the definition, but the question is, do you know what the heck it means? Again, we're not pulling this stuff out of thin air. It's not where we're making it up. We're going to do it right in front of you with the drawing, and you should understand the drawing and what these pieces mean. The whole idea behind this course so far has been to answer one question. What is that chief question we're trying to answer? What is the slope of the line tangent to a function at a given point? Okay, so we kind of had most of it there. Okay, good. I'm going to call that point A. I'm going to call this function f of x. What is then this y value? F of a. Now, unlike the previous definition, I'm not going to choose a second point to be x. Rather, my second point, I'm going to choose to be x plus h. Whoop, I'm sorry. Sorry. A plus h. Sorry about that. People watching this video who already know calculus, you'll know why I made that mistake. So, maybe you don't know anything. So, all right, what's the y value? Who can tell me the distance between A and A plus H? It is H. Okay? So, when you get back, we are going to construct the definition, and you should have an aha moment during that time. Go get some brain food. Come on back. Okay, here we go. This is where we left off. Okay? I want to find the slope of the tangent line. I don't know how to do that. So instead, I find the slope of the secant line. In order to find slope, I do y sub 2 minus y sub 1. What is y sub 2? If you don't know where we got that from, you will not understand the problem. I'm doing slope right now. F of a plus h minus f of a. All over what? A plus h minus a. What happens? Okay, a couple people have light bulbs going off. Spencer and Aaliyah, what are you guys noticing? We've definitely done this before. I had you guys do this in chapter 2 last year as we were talking about average rate of change of functions. And we used that. The difference is now we are going to make it into calculus. We found the slope of the secant line, but in calculus we want to find the slope of the tangent line. So what needs to happen to a plus h? It must move closer to a. I'm going to make that happen by focusing on h. What do I have to do with h? Make it smaller. So if h is going to get small, I want h to approach what? H will approach 0. That's the second definition for slope of a line tangent at a given point, and is the basic introduction for what we refer to as the derivative of a function at a given point. Derivative means the rate of change of a function at a given point, and that's what we're going to practice right now. You are in the middle of differential calculus, and differential calculus really means that we're finding derivatives. You're going to hear that all the time. Today we're going to look at this definition because you guys are familiar with it. But on tomorrow, we're going to investigate the deeper meaning of a derivative and some of its applications. So, take out this worksheet. Does anybody not have a worksheet? I thought I had somebody hand those out. All right. All right. We are looking at the function x squared minus 1 for an x value of 2. You can replace x with a. It's the same thing in this scenario, okay? For an a value of 2. So we're trying to find the slope of the line tangent to the function at that point. Today, you are not going to, thank you, Emma, you are not going to write the equation for the line tangent. You're simply going to find the slope, okay? Because I know you can write the equation for the line. We're just going to make this quick. All right, so I'm going to fill in this. I made a graphic organizer so you can help organize your work, kind of like we did last year. If a is 2, then what is a plus h? 2 plus h. If you'd like to write it as h plus 2, that's fine. What does f of a plus h mean? What do I do? Yes, 2 plus h, that quantity squared, minus 1. That's the function with a plus h plugged in. F of a, what's that? How'd you get 3? Awesome. 2 squared minus 1 is 3. You plug it right in. Now we can use our definition. Here it is. Get used to this. This is going to be our bread and butter for a while. I have the limit as h goes to 0. Unlike our last definition, you know, x was approaching 2, or x was approaching 3, or x was approaching negative 4. H will always approach 0 with this definition. So we go ahead and we plug in f of, I'm sorry. I don't have to rewrite that. And notice, people, if you were to plug in 0 right away, you would get f of a minus f of a all over 0, which is 0 over 0, right? This is what we're continuing to battle with all the time, 0 over 0. So f of a plus h is 2 plus h, quantity squared, minus 1. Then what? Minus 3 all over h. If I plugged in 0 right now, what would I get? Still, I would get 0 over 0. We got to get rid of that h in the denominator. So I have the limit as h goes to 0 of, let's square that. What do you get? 4 plus 4h plus h squared minus 4 all over h. Four is canceled. Can I divide an h? So I have a limit as h goes to 0 of 4 plus h. Can I now plug in 0 for h? If I plug in 0 for h, what do I get? That's the slope at x equals 2, or a equals 2. I will now show you how to verify your answer. This is how you're going to check your answer today. You're going to use it by using your graphing calculator. Please take out your graphing calculator. Please excuse my other graphs here. I'm working on another class as well. So I've got x squared minus 1, and I'm going to zoom standard so I can view that function. We all know it's a parabola shifted down 1 unit, but I'm now going to show you how you check to see what the derivative is. You go second, calculate. One of these up here means derivative. Do you know which one? Y6. The d literally means the change in y divided by the change in x. What do we call change in y over change in x? Slope, rise over run. That's the instantaneous rate of change, the instantaneous slope at a given point. So we press 6, and what I don't like about this calculator is it doesn't ask me a question. Like, it doesn't say, what do you want your x value to be, okay? I just tell it. I just say, I want to use x equals 2. I hit 2, grabs that, I press enter, and it says dy over dx is 4. Those of you with the fancy dancy calculators, it's going to give you both the dy over dx as well as the coordinate. But we know the instantaneous rate of change in is 4. So you don't have to write the equation for the line and graph it in order to check your answer. You can just do that. We good there? Let's do one more problem together. Please turn to problem number 10. What is a plus h? I'm going to write it as h minus 7. Are you okay with that? Instead of negative 7 plus h, I'm going to do h minus 7. So, Michael, we're calling this our a value. So we have negative 7 plus h, which is h minus 7. Okay, so f of a plus h would be negative 3 times the root of 2 minus h minus 7. What is f of a? Negative 9. How'd you get that, Emma? Plugged it in. So I have the limit as h goes to 0. Yes, you have to continue to write the limit until you plug in 0 for h. I have negative 3 root of 2 minus h minus 7 over h. Whoop. Minus the negative 9, so plus 9. What do I do? Spanish, thank you. Do Spanish. Multiply by negative 3 root of 2 minus h minus 7 minus 9. For all you watching on YouTube, that's our joke. When we multiply by the conjugate, we say you do Spanish. It's really funny. They're just going nuts in here right now. Shut up! Oh, gosh. Limit is h goes to 0 of. Multiply at top. What do you get? Somebody tell me. Positive 9. Jill, it's not okay to laugh at people when they say dumb things. 2 minus h minus 7. Then what? Minus 81. All over h times the quantity, negative 3 root of 2 minus h minus 7 minus 9. So for those of you who were missing the algebra that you got so used to loving over the years, this is the algebra of calculus. So you're going to do a lot of algebra in this unit. Okay. Limit as h goes to 0 of. Distribute the 9. What do you get? 18 minus 9h. I think it's going to be a plus 63, isn't it? Plus 63 minus 81. All right. This is what I love. It's like, how could things really cancel? I mean, it just looks ugly. But you got to trust that 0 over 0, we can figure it out. And so what do you notice? The 18, the 63, and the negative 81 will go to 0. because 18 and 63 make 81, and you have a negative 81. And then the h divides off. So you got the negative 9 does not divide off. The limit is h goes to 0 of, we got negative 9 on top. On the bottom, we got negative 3 root of 2 minus h minus 7 minus 9. That's like saying that 3 over 3 plus 5, you could just take off the 3's and get 1/5. Can't. Very intelligent. Thank you. All right. Let's plug in 0. Plug in 0 for h. What do you get here? 9. Square root of 9 times negative 3. Negative 9 minus 9. Negative 9 over negative 18. Positive 1/2. That looked exciting to me, so I'm going to go to y equals, and I'm going to type in that function. What's the function? Negative 3 times the square root of what? 2 minus x. And I'm going to calculate the derivative, number 6. There's my function. Looks crazy. I'm going to check it at what? Negative 7 and 0.5. Uh-huh. Yeah. I let you know now. Thanks, B-Road. You know your assignment, folks. Do not fall behind on your homework in this unit. This test will jump up and bite you. In terms of difficulty, I thought the last test was a 2. 4. 5. Carl, you have such a potty mouth. It's kind of embarrassing.